Yeah, hello, everyone. Yeah, very happy to be here, share experience, and have great ideas. My name is Zijin Zhu, mining engineer for joint venture between Iamgold and Sumitomo. So in the coming up to the 20 minutes, I will talk about the implementation of the remote operation project at Essakane, West Africa, where I worked for 5 years as technical service coordinator. The driver for automation was to improve the safety, consistency, and efficiency of the drilling process, with the cost savings through the continuous improvement. Here is the who we are. We are a gold mining company. The company has 3 the operating mines and the 2 development projects on the 3 continents. Recently, last September, we just kicked off the construction of the Côte Gold project in the province of Ontario. So Essakane mine is the Burkina Faso largest mining investment with an annual production about a third of the national production, has the 2,500 employees, 97% are national. The mine is located in the northeastern part of the Burkina Faso in the border area with the Niger and Mali. The production began in July 2010. The expansion at the end of the 2013 has extended life of mine until the 2026, 4 years more. And the latest the study to boost the plant capacity will once again extend the life of mine at least another 5 years until 2031 and far away. The cycle of the mining operation is conventional, including grade control RC drilling, production drilling, blasting, loading, and hauling. The mining capacity is about 55 million tons per year. The production continues 24 hours a day in a very challenging climate, arid and hot, where the temperature can rise to 50 degrees Celsius and a strong seasonal variation in the rainfall. As I mentioned, the life of mine has been extended via a very careful strategy and continuous improvement. So the technology and innovation played a very important part in this big picture of the expansion. During the startup of the mine, the required fragmentation size was not very difficult to achieve because the ore was coming from the soft area, highly weathered and fractured. So as the mine depths increase, the material is harder. So the blasting fragmentation became harder to achieve. At the same time, as the percentage of the hard material increased, the productivity of the crusher became a concern and bottleneck. It was in this context of the optimization process, some new technology has been implemented. The deployment of the drilling automation was in this big picture. Before the 2016, and we needed 2 people to operate the machine, one for guiding the machine, the other people for operating the machine. It was not safe and efficient, and the biggest issue was the whole deviation, and it's the quality control for the blasting the fragmentation result. So now, the 2020, we have 1 people can control 1, 2, or 3 machines at the same time. So we have a big picture and we have an idea on what we are going to do. So we opted for the phase approach to follow this automation. We broke up into a smaller piece and then step by step put this piece together to gradually keep going toward our goal. So actually, all the machines are, are already designed and ready to be run fully autonomously by the OEM system supplier. Some options have the interdependency with each other at the option to allow progressive uptake of the all automation the technology. So it's very flexible. Just buying a car, a Tesla car, you can have the basic option. And then if you like, you can upgrade the software to full self-driving capacity. So for us in the stage one, the green color, and we have the operator assist function. So that means one or more steps of the drill cycle are automated. Only the requirement is we just only require some the human intervention. And after the successful story of the stage one, and then we go to the stage two. So we evaluated the stage two. The operator are removed from the machine, and one people now can operate one, two, or three machines remotely at the same time. So this phased approach implementation provides some benefit for us. Firstly, reduce the management challenge. Secondly, reduce the investment risk. And thirdly, we don't expect to change the people overnight. So the people need the time and experience to learn and to be a master of the technology. So we show the people how the system works, and we can prove it and master it, and then we move forward. So for the business case study, actually it's a trade-off the study. It's the CapEx and the OpEx, the trade-off study. In the last 2018 line of my study, the different scenario demonstrated that our production will experience a very significant increase in the total material mined. The hard material from the phase 4, 5, 6, and 7, where the the high stripping activity reached the ore zone from the 20 and the 26. This significant increase in the production put a lot of pressure on the operation to build inventory to ensure timely phase the development. So it was in this context, we have a semi-autonomous option trade-off study. So the increase in the productivity will make it possible for us to follow the mine plan. We now having to buy the equipment. So as we know, drilling actually is a manufacturing business. It's a game of the efficiency. The improvement objective is obvious. It's the speed, the drilling penetration rate, setup and popular efficiency, and the time usage, the launch and the shift change delay. So the major benefit is increase the production by increased equipment utilization. Typically, for us, one machine is scheduled to approximately 6,310 hours per year. So our objective is to have an annually increase the utilization and about 645 hours, and increase the penetration rate about 3 meters per net operating hours. So 645 hours operating hours, we can have about 14,835 production meters per year per rig. So keep operation no stop. That means we can get more operating hours. So it's a trade-off with the technology. So implementation at the Burkina Faso, mining regulators are not requiring us to put together what we call the project management plan before we could go ahead with the autonomy. However, considering the hidden complexity in a project in such as West Africa, we have limited technical resource, logistic challenge, and the old habit change for the people. So we place huge focus on the detailed checklist. We have a master project plan for the change management and very big package of all the information. So we made people aware very early on how we approach the implementation and the technology, how the system going to work. We bring them on board, and at the end of the day, we clearly show the people we are ready to operate and we are safe to do it, and it's safe for the people to work and it's under control. So sometimes the people are scared of the automation. It's the same in the West Africa. The people has the resistance to change. So we deploy the story to be the communicated, help the people understand. We still need the people to operate the machine and didn't remove the people from the job. So the remote autonomous machine is a technology to assist them to enhance the safety and efficiency, and becoming a remote controller themselves is a job enhancement. So have buy-in with the different stakeholders directly affected by the introduction of the technology. So automation is new for us, but I believe it's not new for the OEM system supplier. So much of the risk are controlled by the safety system of functional safety. Outside the functional safety to keep the workplace safety, and specific process for controlling associated risk of the remote operation have been reviewed at our end. We have critical procedure in place to ensure workplace safety. For example, we understood the safe design will only be successful if the process is controlled. So a master plan has been developed and a sign-off process by different stakeholders was put in place. All the best practice and the lesson learned have been summarized as a checklist in the master plan. And the other very important is the pattern clean up and preparation. It's a very important step in the production process. So it's critical to ensuring the safety and efficiency. An uneven flow can increase the machine movement cycle time, and at the same time, the risk of the load over. So the floor elevation of each bench was followed closely, and the broken material has been dug to the grade, and with the help the high technology, for example, HPGPS, the system guidance, and the UAV surveying. So in the solution from the system, the supplier has reached an advanced stage after the development for over the past 10 years. We like it. The deployment actually is quite straightforward. With the current state of automated system and deployment and the competence and the support from the OEM system supplier, it's unlikely that an automated system deployment will fail. It's often as simple as plug and play. You power on, and voila, it works. Now you can stay in the office and control the machine. So Our operator like the system very much. For us, it's a better, faster, more efficient, and safer mining process. We can see in the right picture, we have improved hold quality and consistency. You see the two hole here, it's exactly just like the same. So we are happy. And when you see the right picture, in the hole, the position is very good. There is no deviation compared with the design. So blasting engineer is very happy. And and the operator are happy because the operator now more comfortable, no dust, no noise, no vibration, no high temperature. They would not go the other way. So they don't want to go back to the cab to operate the machine. And for us, it's a way to improve the staff motivation in the workplace. And and at the same time, fewer the people in the dangerous area, we reduce the risk frequency. So the next slide, what I want to mention here is the OEM system suppliers autodrill second generation. It's a big advanced opportunity or large part for the automation. The system is very smart and could continuously optimize the ground engagement to deliver the desired result. The, the only input required by the operator is here, and its name is the aggressiveness setting, which balance the bit life against the penetration rate. So the function is ease of the usage. However, uh, what I like to mention here is if we want to ramp up the full system capacity, we still need a drill master, someone know how to do the fine tuning. In the people, process, technology, you need fewer people, but higher skill. In this regard, automation of the machine is not a magical solution for all the production problem. And next slide, I will just talk about the system, the system and the configuration. Actually, the OEM system suppliers solution is very flexible in its configuration. And we can use IP the security protocol or the network area translation one-to-one of network area port translation protocol, NAPT. Yeah, the last one is NAPT is only used for the LOT, the communication. In our case, we use the Cisco Wi-Fi in the mine, so we use the NAT one-to-one. The westernmost is a gateway. Here, the green color, it's a layer 2 implementation used to separate the internal and external device. And here, the green one, it's actually the stage one. It's the data portion. It's before we move over the remote operation. It was already in place. It's the data portion. It's the production data or drilling plan is sent through the common communication interface, transferred between the machine and the office, the database. So here the communication requirements are not very critical. And the blue one here, it's the control portion. It's the safety system, video encoder, ACMS interface, and operator station. Or it's terminated at here, the westernmost gateway. and is ready to integrate to the my wireless or the virtual LAN. It's a critical requirement to have a reliable network connection between onboard device and the office device. So the yellow one, or no, orange one, yeah, it's the GPS. The GPS system is commonly outside the automation on board VLAN, and it's on a separate my wireless LAN as the end user device receive the data collection from the GPS base station. So here it's an example of our the NAT one-to-one configuration network address translation table. So you can see all the onboard device need the my VLAN IP address for the communication between the onboard device and the remote office. So the gateway and the west mode is to translate an internal IP address and external IP address. So all the setting, like for example, the VLAN, the private VLAN setting are all the same on the machine. For example, 625, 627, 626. Yeah. So they are standard. So they are the standard IP address. Sorry. So yeah, it's if you understand, it's quite straightforward. So actually, and the machine you can preload all the configuration, and then the machine came to the my side, and you just the plug, and it will play, plug and play. Yeah. So the next slide, it's the remote onboard system, and an access point is used for the point-to-point communication between the machine and the remote office. And we have the machine safety unit. Yeah, it's connected to emergency stop circuit used as the high priority safety device. So just like the heartbeat over the network to ensure a stable network connection. If the communication is lost between the machine and onboard device and the operator station, and then the machine will go into a fail safe mode of the stop. And the other side, we have the video server unit. It's used to compress the video streaming from the camera. And we have the other, it's the PTZ camera. It's the other side of the machine. Unfortunately, we cannot see here from the picture. So it's another camera, very important. Yeah, located on the machine cap and can be controlled remotely from the operator station, just to see all the operating details. Yeah. And here is the overview on the remote control office. Yeah. So the big one here, the machine, the box, it's the rack, it's the on-site rack, is a central hub for the operations center control and monitoring all the autonomous fleet. It can, and it's scalable. It's scalable to the three the operator station and reach the 9th machine. Here is the safety master, one safety master for one machine. So currently we have just the remote machine. So we have the 3 safety master. And the small box here, it's the linking box. The green, the status light indicate whether or not the safety units are okay. Yeah, if it's blinking green, it indicates the link is in progress. It's in progress, but not yet completed. So the operator just need press the button to link the master and the safety the system. If it's solid, so solid green, it means it's okay. Everything is under control. Yeah, like for the communication. And yeah, here it's the operator station. Yeah, the picture. So it's exactly the same as the operation interface in the machine. So it's very ease of use for the operator. And yeah, the other one here is the automation command machine server. It's just like a coordinator. Yeah, ACMS. It's just like a coordinator, and it coordinate the all the remote operator station and the rig, the machine. Yeah. So yeah, the some of our reflection, we had a project built in from the operators, from the management and leadership at the all level, and yeah, and from the OEM system supplier. Technology is common and is usually not an issue. The deployment and the commissioning have too longer time due to the some unexpected event. Yeah, so the well-designed change the management plan and adequate maintenance training program are high on the order list or the challenge. And automation implementation project lead or the champion, normally, as our understanding, should have a love for the technology with the mind operating experience and understanding all the information, ICT, information and communication technology. So the sensor are very important for automation. The sensor is just like the eye of the set. Yeah. So this places a higher requirement on the system maintenance service. And the network communication is key to successful remote automated operation. The wireless system must in top shape. We we have we, we already have the backbone and the connectivity in our mind before the remote operation for fleet management system in real time. But latency, the delay in the data transfer is more important for the remote control than the fleet management system. Yeah, it's different. It's the other experience for us. We show the people and the stakeholder a big picture on what we are going to do. Sometimes the people just doubt if we be able to get there. Yes, the technology is new, the people are uncertain, and we do not have a clue. Nobody has got a ton of experience with how all the things work and occurred. But we see the technology as a low stake as a low stake bet with a potential large payoff. So we still need to be there. We prove it and we move forward. So we are. So the next step for us, we know the communication and sensor are very important. All the system or the sensor must 100% error-free to allow the remote autonomous operation. So we will look for a wireless network solution of preventive action for the communication and maintenance. And we will document, descendant, and develop a preventive system maintenance checklist. Yeah, we like the checklist. So yes, the most important, we put the money and and time, we want to see the return. So we will ensure the safety process updated and in place and ensure continuous improvement to achieve our business objective. So the future, yeah, moving toward the automated mine is the way of the future for Iamgold organic growth pipeline. So both the autonomous haulage system AHS and autonomous drilling system ADS was selected to be applied in our Côte Gold project. We will maybe probably be the first the fully autonomous Canadian green project. Yeah. So we are very excited about this digital future. We believe that the success of the automated operation is achievable by anyone willing to put the time and then investment. Yes, that, so yeah, thank you. That's that's the end of my presentation. Yeah, it take a lot of
Thank
more
you.
time. Yeah, sorry.
Don't worry, Sue. Thank you so much. As well, probably you didn't saw that in the chat. There's tons of questions, which means that it was a great presentation. So thank you so much. I will probably, due to the time, we will just be able to cover one question that actually have two questions there. And for the rest of you guys that ask questions, don't worry. I will talk with Sue after today's presentation, and Sue will help us to answer those offline, and then we will make it available for you guys through our email that we're gonna send you guys next week, as well as Basecamp. So. Sue, here we have a question from Brian that it was the first question that came in. Is instantaneous penetration rate increased or just drilling hours? Is there any quality trade-off loss with increased penetration rate?
And yes, yeah, and we the last week, and I just look for our drilling pattern. So we compare the manned operation with the TeleRemote operation, yeah, and automation. And one, for example, for the rate of the penetration, manned operation is about 25.5 meter per net operating hours. And remote operation is about 30. It's about 30 meter per hour. So when we do fast calculation, it's about 70%. Yeah. So for the setup time, it's not a big difference. And for the moving between the hole from one hole to the other hole, it's not a big difference. The biggest, yeah, for us, it's the rate of penetration, yeah, for the moment. And sure, the other is, as I mentioned, yeah, it's the time usage. So before we take the 2 or 3 hours for for example, for the lunch break and the shift change, and now we can keep the machine no stop. So it's a biggest, yeah, it's a biggest part for us.
Perfect. Thank you, Sue. And I'm just going to do one last question and we will move forward with the next topic. So here's a question from Delphine. How long does the bench cleaning take approximately? I assume it's easier since the material at this site seems to be more on the fine side.
And normally it takes long time. Yeah, it's not an easy job. Sometimes it's the battle between the engineering department with the operation. So we push hard. So that's why when we do the planning, we require the operation 1 week before for the pattern prepare for the pattern clean up for the autonomous drill 1 week before. We don't wait for the last minute because the last minute it's always the battle between the engineering department and the production guy. Yeah. So it's most important. it's not an easy job. It's not just the engineering work. So that's why we plan ahead for the clean up, for the clean up work 1 week before.